Hello. This is my first class on trigonometry fundamentals. If you want to know more about these videos and myself and what and why it inspired these videos and everything that I've been doing on this channel, you can visit my I'll put a link onto this video. You can check through the channel and then you'll see the introductory video where I introduce myself and talk about everything and what this channel is about. But here we'll be focusing on trigonometry and the fundamentals of trigonometry. This is a very interesting topic, which is also quite a very big problem within the South African curriculum. It causes a lot of problems for students. And I think the gap is actually the basics, because mathematics is basically the basics. It's about axioms. If you understand the axioms, then it's very easy to develop almost any theory from any axiom. In fact, one of my hobbies is developing or finding different proof to accepted theorems using different types of mathematical truths. So I'll make an example here. When we go along the way, you'll find that for some trigonometric identities, I have a lot of different proofs, and some of them I worked on them myself along the way while learning different techniques. And then I saw that I can use this technique to actually go and prove the theorem. And then it's just the fun part of mathematics, that when everything clicks so well in terms of understanding the basics, then it can be really a fun subject. So in this case, I want us to go through trigonometric fundamentals, and then there'll be a lot of things that you're going to be looking at, but the basics here is going to be a lot of history and a lot of development of the subject. As you'll see as we go along the way, that there'll be a lot of aspects on the development of the subject and some background for every concept that you're going to be introducing. But to check more, you can visit that site there. I'll probably post it or I'll put it on the link. I'll put this link below in the video. So you can go there and read a bit about trigonometry and the applications of trigonometry. But the objectives here, what I want you to get from here is from this video and the following series of videos on trigonometric background is on trigonometric fundamentals is the background part of things. So I want you to get an idea of where trigonometry comes from, the background. We can't cover everything, of course, but as you'll see, as we develop every concept, we'll put on some background into it and try to explain it. So the background will be part of all these videos on trigonometry. Everything we do in trigonometry will have some bit of background into it. You also have to get a proper understanding of basic trigonometric concepts, understand and evaluate values of trigonometric ratios in relation to angles, understand and utilize special angles to find solutions to special trig ratios, utilize the Cartesian plane to develop cosine and sine sinusoids. That's a very interesting topic, because when we're talking about trigonometry, you'll see that we start with a plane angle, a right angled triangle, but this is going to develop into sine sinusoids, it's going to develop into wave analysis, it's going to develop into a lot and a lot of stuff. It's going to develop into further mathematics theory analysis. I hope we'll get there in the future, but that's advanced high engineering mathematics. In a sense, it's high institutional education mathematics, not limited to just engineering. You also have to understand and solve trig equations, and then you have applications of basic trigonometry. So this is, in a sense, a framework of grade 10, but it's taken deeper than that, because I think trigonometry is introduced in grade 10 in South Africa, but this I'm taking it deeper than that and going deeper into the analysis and giving you a proper introduction into trigonometry. So in this section, I just want us, with all that being covered, I just want us to look at something very nice here. We do have the unit cycle. We do have the background of trigonometry, but I'll cover it. And we do have the unit cycle here. So we're working a lot with this cycle, because almost everything about trigonometry is here. From this cycle in this plane, if we take the cycle and put it in the Cartesian plane and analyze it using the Cartesian plane, we can develop any trigonometric theorem that you know, or any trigonometric truth, axioms, everything. So we'll be working a lot with this cycle. You'll see it a lot in our future videos, especially once we get to sinusoidal analysis of trigonometric ratios. Then we'll and also when we're solving trigonometric functions. So when we're looking at the background, trigonometry is a very nice field. It was developed a long time ago, and the basic idea was that we are using angles in combination with metric. So that's where we get trigonometry, because that try them, because that try in trigonometry, that try actually equals to 3. So in this case, we're talking about 3 sides, because that's what trigonometry is about. It's about triangles. Triangles have got 3 sides. And then we have cone, which derives from Greek terms, and it actually refers to angle. And the term angle is derived from Latin language, and the Latin language, in that it means, in Latin it's derived from the Latin word which is called angulus, and angulus actually describes a corner, or in this case a vertex, So, and then we have metric, which is for metric. We have the metric system, and when we're talking about metrics, we're talking about measurements and the system that we use to measure things up. That's why I have something called the metric system. It's a measurement system. The metric system is derived from the term metric, which is a Greek term meaning to measure. So, with all this being said, this term then, it just means that here what we are doing is that we are using triangles and angles to make measurements. That's what we're doing. Triangles plus angles, this gives us measurements. That's all we are doing with trigonometry. That's the basic of trigonometry, but then we'll see as we develop it. And also, it's a very nice field because it's developed on a very specific analysis. The fundamentals are developed on very specific analysis. They focus on the plane triangles. So when we're talking about a plane triangle, we're talking about a triangle that has got a right-angled angle. I'll describe what an angle is now, but you must have an idea from there, because we talked about the angulus, which is a corner or a vertex. So I'm sure you have an idea of what an angle is and what it kind of measures. So that right there is what we call, this here is 90 degrees. So we measure in degrees when we're measuring angles. So this here is a 90-degree angle, and 90-degree angles are called right-angled triangles. Now, as to why we use degrees and all that to measure to measure angles, that's another story, another development, because it also uses base 60 for measurements. It also uses, it's a calculation method that uses base 60 that we use for angles, but then there's a lot of history to that. We're not going to go into that. But then now I just want you to understand that an angle is a unit of measure, and then what it measures is that when you have two lines that are meeting at a corner, that corner right there is called a vertex, or you can just call it a corner. And then the space in between those two lines, the separation between those two lines, when they come out of that vertex, is called an angle. That's the measure of the separation, how very opening the lines are coming from that vertex, how very special they are when they go out from the vertex. That's what we call an angle. And this will be the fundamentals of trigonometry, the introductory video, entry 1. Also, one thing that I want us to also look at is that we're talking about using angles and three-sided triangles, or in three sides shapes which are triangles to make measurements. But what does in essence that actually mean? You will understand. Let's say one very practical example. Let's say you have a building here, and then that building there, you want to measure the height of the building. This is the height h of the building. So it's a very nice 5-story building. And then if you climb on a lift and then go to the top floor of the building, and then hook a rope around there, and then take that rope down, throw that rope down, and then come back down, and then go and stand at some position where the rope is fully stretched. The tension of the rope is very nice and special. In a sense, it doesn't have any slack. and then in that point hook the rope on something and then measure this distance here, and this forms a right angled triangle. Those there are perpendicular lines are perpendicular to one another, which means that they intersect one another exactly at 90 degrees. So in a sense, this then becomes what we call, this then becomes a triangle. But then within that triangle, if you measure this distance here, which you can just use a tape measure. Maybe let's say this distance maybe is 10 meters. And then with that angle and this distance here and this angle here, which you can also measure using a very big protractor, you can actually be able to calculate the height of this building and be able to calculate also how far the length of this rope and all those stuff. But then this is a very trivial idea as to what they used trigonometry for. You need to remember that in ancient ages they didn't have these sophisticated tools that we have now to be able to make these calculations. So this idea alone was very fundamental and very important in the ancient world. And then going further again, we can look also at trigonometry in a form of relations. So we actually deal with relationships between sides and angles. Like we said we have tri, which refers to three-sided shapes, which are triangles, and then we have angles. So what we're dealing with is relationships between these two. And for something to have a relationship, there is something which is called a function that we can use to relate two entities in mathematics. In any case, in anywhere, even in the manufacturing industry, you will understand that there are things, they talk about inputs and outputs. So they're saying if I do this, that's an input. If I'm pushing something, that's an input. So if I'm pushing a wheelbarrow, I input some force onto that wheelbarrow, and then the wheelbarrow is going to move. And then the speed of the wheelbarrow is going to depend on how much I'm putting on. So the speed of the wheelbarrow or the movement of the wheelbarrow is going to be my output movement. So I inputting force, and then I get displacement or movement of wheelbarrow as my output. But then these can be related together. But you see when we're doing stuff in physics and learning a lot about relationship between force and displacement in physics, then you will see this also coming up again. So this is the case also with trigonometry. This is what we're doing, just taking sides and the angles and relating them to be able to make measurements and develop some very useful mathematics that we can use to apply in many different fields. We use it to apply in robotics, manipulations, we use it to apply in sound analysis, we use it to apply in a lot of different areas, a lot. Measurement, because these are measurements, so anything that can be quantified in this sense or that can take the properties that we develop when using trigonometry, then it becomes part of trigonometry in a sense, or part of application of trigonometry. And that is what mathematics is all about in essence. When mathematicians develop stuff, the beautiful thing is that they don't think about the impact of what they are doing. They develop it in a purely manner. One of my favorite mathematicians, Bertrand Russell and Hardy, they talked a lot about this, that when mathematicians develop these concepts and all these things, they are pure abstract. They're just maths, pure maths for maths. And then you get physics part and then the chemistries and everything and the engineering, which kind of apply this mathematics and these fundamentals that are given by mathematics to quantify ideas that are developed in engineering and in most cases in physics and other fields, which also now extended into economics. Economic sciences also uses a lot of mathematics, and you'll find trigonometry within economic sciences. You'll find a lot of the concepts that we'll be developing here in a lot of places. So that's going to be it with the introductory video, and the next video going to be diving deep into similar triangles and then getting a proper mathematical structure of what really trigonometry is all about.